Welcome to Plutus Project-Based Learning 2023 from Gimbal Labs. Thanks for watching this video. In this lesson, we're going to dive a bit deeper into the PPBL 2023 contributor token that you minted in lesson 100.4. We will use this as just one example that will help us think about the ways we might contribute to new and emerging standards in the Cardano development ecosystem. As we do, we're going to build upon your background knowledge about CIP25, which was covered earlier in this module. And now we're going to look a little bit at CIP68, which is called the Datum Metadata Standard. Let's look at some pictures first. If we are using CIP25 to mint NFTs on Cardano, this is what a minting transaction might look like. Of course, you'll have an output with the NFT in it, and all of the metadata to describe that NFT is in metadata in the minting transaction. No datum is used when we talk about CIP25 NFTs. With CIP68, on the other hand, we don't use transaction metadata. Instead, all of the data relevant to the NFT goes in some datum in a UTXO with what's called a reference token. Because in a CIP68 minting transaction, tokens are actually minted in pairs. One of them is the NFT that goes to someone's wallet. The other is the reference token, the purpose of which is to help us identify the relevant metadatum that accompanies the NFT. This has some really big implications. First of all, datum can be read by smart contracts. This was a big limitation of transaction metadata, and therefore it's a technical limitation of all NFTs minted with CIP25. Transaction metadata cannot be read by smart contracts. Additionally, the way we would build applications changes. To summarize what we looked at earlier, if we're using CIP25, the way a front-end application would be built is you would want to query for the minting transaction for the NFT in question, find the metadata in that minting transaction, in particular with key 721, and then read that metadata to display images or other data in your dApp. The process is different for CIP68. Instead of querying the blockchain for transaction metadata, we query for the reference token that's associated with the NFT. We can get the datum from the UTXO that has the reference token in it, and then we can read that datum to display whatever we would like, image or other data. You might be wondering, can you combine CIPs 25 and 68? You sure can. You can place some metadata in a minting transaction, and you could mint tokens in pairs so that there's some changeable information in the metadatum here. As a matter of fact, this is exactly what your PPBL 2023 token does. It's a partial implementation of CIP68, but it doesn't quite follow the whole thing. In order to display the image that you can see in your wallet when you look at your PPBL 2023 token, we still used the CIP25 standard for that part. The reason we are taking this approach is to invite you in to this new and exciting work. One of the ways you can mint NFTs is by contributing to new and emerging standards on Cardano. It's happening right now. The documentation below this video is an invitation for you to explore. Start by clicking on this link and visiting the new student dashboard. Try connecting your wallet and see what you see. I can see the name of this demo contributor token. I can see the lucky number associated with it, and I can see there's a list of completed modules here. In this example, I don't see a CLI address because this student didn't complete Module 102. What do you think about this? What else would you like to see on a dashboard like this? Now, with the student dashboard in mind, let's think a bit more about how the PPBL 2023 token is a partial implementation of CIP68. I hope that you'll take the time to read through CIP68 on your own, but here's an overview of what's implemented and what's not in the PPBL 2023 token. First of all, we do mint a pair of tokens. In the CIP, you'll see these called the user token and the reference token. In this course, we'll refer to those user tokens as either student or contributor tokens, and we'll use these terms interchangeably. A reference token is also minted and sent to a reference address. When you minted your tokens in Lesson 100.4, both of these tokens were minted. As suggested in CIP68, the prefix 100 is used at the beginning of the reference token name, and the prefix 222 is used at the beginning of the student token name. So in your wallet, you might have noticed that the token you hold is actually named 222, then PPBL 2023, and your alias. We also followed the guidance in CIP68 that there be exactly one reference token associated with each student token. On the other hand, there are several things that we did not implement here. For example, the primary focus of CIP68 is on representing typical NFT data, the name, the image, and the media type properties, just like you saw in CIP25. With the PPBL 2023 token, we didn't use any of that. Additionally, although we're following the pattern suggested in CIP68 when it comes to naming the student and reference tokens, we're not using the exact same syntax for encoding those token names. This is a way of representing the sort of experimental mode we're working in right now. So what are we experimenting with? For one thing, CIP68 does not insist on using any particular kind of Cardano address for storing reference tokens. As you begin to understand how reference tokens work, I think it's a good thought experiment to consider what would happen if you use different kinds of addresses. What if you use a single wallet where one person has the signing keys for moving reference tokens around? What would be the advantages and disadvantages of using a multisig or a Plutus validator, or even an unspendable address where we can send reference tokens but never unlock them? In the case of the PPBL 2023 token, we're storing reference tokens at a contract address. We use a validator to set specific rules about who can remove reference tokens. In this case, it's the teachers of this course, or how datum can be updated. And this leads to a really exciting breakthrough that you'll start to see with the PPBL contributor token. Using Plutus, we can write targeted rules that allow holders of different role tokens to update datum in different ways. As you begin to understand these concepts, the fun can really start. We've got some questions about what the PPBL student token should really be, and you're invited to participate in defining what we do next. The PPBL 2023 token is designed to be changed over time, and when we're ready, we can move all of the reference tokens that exist right now to a new contract address that encodes the datum and the parameters for everything that we'll agree upon over the next few weeks. But it's not a process we'd want to do all the time. So we're going to be thoughtful about it. And we're going to start with a conversation. So here's your task for this lesson. Make sure to navigate to the PPBL 2023 Plutus template on GitLab. This is the repo that we've been using throughout the course. You can see the familiar bash scripts directory here. The contributor token contracts are not yet included in the source directory. We will add those soon. What you will find in the issues list over here. So I'll click issues, and here I can see a list with 3 questions on it. Each of these is a GitLab issue. And this is a space to have a conversation about what we would like to make the PPBL 2023 token to be. In each issue, you'll see some existing documentation. So for this question, what information should be included in the contributor reference contract? There's a description of what currently exists and some questions at the bottom of the page. When you have an opinion and you're ready, you can write a new comment down here. And you can post it. And this will allow everybody contributing to this project to share their own input on each of the questions here. If I navigate back to the issues list, I can see that there are these 2 other questions. What do you want to be able to do with your PPBL 2023 token? We're in the dreaming big phase right now, so please do so. And finally, who should be able to update the contributor reference datum and how? And this is where you can see the validator code that allows us to make targeted changes to datum depending on which role tokens we hold. In this case, the holder of an admin or teacher token will be able to change the list of completed modules, but not the lucky number. And the opposite is true for the holder of a contributor token. Students will only be able to change the lucky number in their reference datum, but not the list of completed modules. Finally, there is a backdoor right here where teachers can remove student tokens from the course. Is this a good thing or a bad thing? Should this be here? Oh, what rules would you like to see in place? Are there processes that you can imagine that we should automate? And what are some necessary and appropriate limits to the power of teachers and admins? Let's start by having this conversation. We will have a chance to talk about these questions at live coding. And as we dig deeper into Plutus, we'll have a chance to implement the things we decide on doing. I can't wait. Thank you, as always, for engaging with these questions, and see you soon.